Alrighty. So my device ran out of memory, and so I was just sitting here for about a good solid 30 minutes talking to myself as my device wasn't recording. So I had to print off a new sheet of paper, and we're gonna have to I'm gonna have to start all over again. But where I left off was just coming up with our game plan and finding the three facts about these two triangles to prove that they are congruent, and then we were going to use CPCTC to prove that the other set of lines are parallel. So again, that's our end goal, is to prove that these lines are parallel. So if we can somehow prove these angles are congruent, then we can use one of those theorems we had discussed earlier. So got my game plan. Let's go. Let's implement it. You always start with one of your givens, and usually you just go in order of how they're listed. So we have that segment GH is parallel to segment IJ, and so a lot of you are unsure about the order in which to write your statements. Well, you always begin with your given, and like I said, kind of go in order as they're listed. And if that given implies something, it tells us something about the two triangles we're trying to prove are congruent, or leads us to a new fact that, towards our end goal, then that's what should come immediately after that given. And we had already discussed that, well, because these lines are parallel, that implied that these two angles were congruent. So that's how I know that this needs to come directly after it. It just logically makes sense to say, well, if these lines are parallel, this logically follows that these two angles are congruent. And as we discussed, we know that, well, if lines are parallel, because that's what we know that the lines are parallel, then I can conclude that these corresponding angles are congruent. So remember that this is a conditional statement. It's an if-then statement. So the first part, that first clause, is the hypothesis. The second clause that follows then is the conclusion. So your reason here, the conclusion of that needs to match what you are concluding. If I'm saying that these angles are congruent, then that needs to be the conclusion of my if-then statement. So this gives us that first piece, or one of the pieces, one of the three facts about these two triangles. The other two were freebies. They were just given to us, so we're just going to go ahead and write those out. Because I need to write the first, I need to write the three facts that I know in order to prove these triangles are congruent. Those must show up in my proof. I have to state them. So this was given to me, the fact that angle H is congruent to angle J, and then also I was given that segment GH is congruent to segment IJ. That was given to me as well. So now I have my three facts about these two triangles. I have stated them, I have listed them, and so now I'm ready to say that these two triangles are congruent. Now in class, I know that some of you wanted to combine these two steps and said, well, these two facts were just given to me, so why can't I say that angle H is congruent to angle J, and I also know that these segments are congruent as well, and both of those statements are justified by the same reason, that they were given to us. And so you thought to yourself, well, I now have the 1, 2, 3 parts that I need, so I'm ready to say that these triangles are congruent. And you kind of got confused. You said, well, what goes here? I'm ready to jump down to step 5 and say that these triangles are congruent. Well, the author of this proof intended you to split up all the givens, and so this was that's what was supposed to go there. But if this ever happens to you in a quiz or in a test, like if this happens in the classroom, you just need to raise your hand. I'll come over, and you can just say, well, Mr. Niven, this is what I want to do. Am I allowed to do that? Because I'm confused about what goes here in this fourth step. So I will look over your proof, and I'll either say, yes, that's absolutely acceptable. You do not need this fourth step if that's your game plan and that's how you implement it. But understand, sometimes I'm going to have to say, no, you can't do that. You skipped a step. You can't just jump to that conclusion, so on and so forth. So have confidence in yourself and in your game plan. And if that happens, just ask. Just ask a question. So we're ready to prove these triangles are congruent. So triangle GHI is congruent to triangle IJK. And because we have this angle, side, angle, and so that is our justification, angle, side, angle. Now, I just proved two triangles were congruent, so I know that the next step is I'm going to use that as leverage. I'm going to use that to my advantage and say that other parts are congruent because of CP/CTC. But there are three facts that I could write. I could say, well, because of CP/CTC, this segment's congruent to that segment. I could also say that this segment's congruent to that segment. And then I could say that these angles are congruent, because all three of those are all justified by CP/CTC. And so you need to choose one of those three that would help you prove that these lines are parallel. So you need to analyze and say, okay, well, what's gonna help me prove, what's gonna help me reach my end goal? Well, the fact that segment GI is congruent to segment IK, that's a true statement, but that's not going to help you prove that these lines are parallel. The fact that segment HI is congruent to segment JK, again, that's a true statement because of CP/CTC, but that's not going to help you prove the lines are parallel. It is the fact that these angles are congruent. And then we're going to say, well, these are corresponding angles with these lines cut by transversal. And if corresponding angles are congruent, then I can conclude that lines are parallel. And so that is how I know which statement to write next. It all has to help you get to whatever your end goal is. So angle GIH is congruent to angle IKJ because of CP/CTC. Now I can end with my end goal where I was heading the entire time because of one of those theorems we were talking about earlier. We know that we can prove these lines are parallel, that if corresponding angles congruent, then lines are parallel. So this is one of those proofs where you're not going to stop at CP/CTC. That's going to help you towards your end goal. All right, moving on to the next page. We've got 4 more proofs. There's 2 on this page and then 2 on the next as well. And I highly suggest that you try these on your own and just use this video as either like a key just to check yourself. And then also, if unfortunately you get one of these statements wrong, then it's a learning tool. You got to learn from your mistakes. Mistakes aren't bad. Mistakes are proof that you are trying. And so that's the beauty of it. You can't get discouraged. You can't get upset. You just need to look at it and say, hey, I'm not perfect. I'm going to make some mistakes every now and then. So let's learn from these. Make sure they don't happen again. So again, I encourage you to pause this video and try these on your own and just use this as a key to grade your proofs. Okay, for number 6, coming up with a game plan. We're trying to prove that angle STU, so this guy is congruent to that guy. Again, ask yourself, how do I know, what are the ways I know to prove angles are congruent? You can kind of go through that list. I noticed that these 2 angles are corresponding parts of these 2 triangles. So if I can somehow prove that these triangles are congruent, then I can use CP/CTC. So let's see if I'm able to prove these triangles are congruent. And again, I'm not writing steps in this proof yet. I'm acting like I don't see any of this. I'm just coming up with a game plan. This is like the outline of my English essay. You don't just start with your final draft. You do some brainstorming. So that's my game plan right now. Let's see if I can actually make it work. So I've got that these two segments are perpendicular. That's already marked in my diagram. So that can lead us to a couple of places. We can say, well, these two triangles are right triangles, and then maybe I can use HL to prove these triangles are congruent. But then I look and I say, well, this second given says that point U is the midpoint of SL, so that means that implies that segment SU is congruent to segment LU. So then I was like, well, if I want to use hypotenuse leg to prove these triangles are congruent, I need to somehow prove that these two hypotenuses are congruent. Well, as of now, in my diagram, there's nothing that tells me that those two segments are congruent, and I can't use either one of these givens to get to that conclusion. So I can't prove these hypotenuses are congruent. So I'm not going to prove these triangles are congruent by HL. Now that's okay if your original plan doesn't work. That means you just got to go back to the drawing board and ask yourself, okay, how else could I prove that these triangles are congruent? Well, you notice that in the diagram, these two triangles share segment TU. So I know that segment TU is congruent to itself, and that is justified by the reflexive property of congruence. So now I see that I have a side and another side. So if you go through the list, side, 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 angle, 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 side, and HL, these are the 5 ways to prove triangles are congruent. We've already said HL doesn't work, but we do have 2 sides that are congruent. So maybe I can find the third side is congruent, and then maybe I can use SSS, or side, side, side. But again, we look and we say, well, I don't know how to prove, or I can't prove that segment ST is congruent to segment LT. So I can't use side, side, side. I don't know 2 angles, so that goes with, so that eliminates these. So I'm left with side, angle, side to prove that these 2 triangles are congruent. So maybe if I can prove that the included angle of these 2 sides are congruent, and if I look at my diagram, the included angle, or the angle in between these 2 congruent sides, those happen to be right angles. They both are right angles, and I know that because of this given information. So the fact that these segments are congruent, that implies that angle SUT and angle LUT are right angles. Because that's what perpendicular means. It means 2 objects intersecting to form 90-degree, sorry. 2 objects intersect to form right angles. That's what the definition says, that they form right angles. And by objects, I mean you can have lines, rays, segments, planes, but if 2 objects are perpendicular, then right angles are being formed. So from this given, I would have to say that right angles are being formed, that those 2 angles are right angles. Then from there, I can say that these 2 angles are congruent to each other because all right angles are congruent. So be careful that you don't go into talking about how their measurements are 90 degrees. That's not what the definition of perpendicular says. It doesn't say anything about 90 degrees. It just says that they are right angles. So I noticed that in class that some of us wanted to talk about 90 degrees, but be extremely careful and know exactly what perpendicular says, what that definition says. So now that I've proven that this angle is congruent to that angle, I can say these 2 triangles are congruent because of side, angle, side. And now that I have those 2 triangles are congruent, then I'll use CP/CTC to prove that these angles are congruent. So I've got my game plan. Now I'm just going to execute it. Only after I've come up with a game plan and I know exactly how I'm going to start and finish this proof.